In Module 11 and 12, we are going to talk about similarities, so not shapes that are congruent, but shapes that are similar. Before we get into that, we need to remind ourselves what a ratio is. And a ratio of A to B can be written as A over B as a fraction, or you can write it as A, B, like so, as long as the B is not 0, because we can't divide by 0. Ratios are written in simplified form, so we can always remember to reduce them. Equivalent ratios means that we have two ratios that have the same simplified form, because equivalent means that they are equal to each other. In number 1, when we need to find the ratio of width to length, that means that we need to put the width first, the length goes second. Then we can look at our picture and we can see the length is the 10, the width is the 6, so we would set it up that way as 6 inches over the 10 inches. We know the inches are going to cross out, and then we can reduce the 6 over the 10, and that becomes 3/5 for our final answer. So number 2, we have 240 students eating lunch. 96 purchased their lunch, and the rest of them bought a bag lunch. What is the ratio of students purchasing a lunch to the students bringing a bag lunch? And I want you to set up the ratio of this one on your own. You should have set up purchasing over bringing. The purchasing is 96. The bringing, we would have to subtract. So you have to take 240 minus the 96, and we get 144. So it'd be 96 over 144. When you reduce it, you should have gotten 2/3. A proportion we've seen before is an equation that states that two ratios are equal to each other. And if you look over on the far right, you can see that we have a ratio set equal to a ratio. So we have two ratios equal to each other. Now the cross product property means that in a proportion, the product of the diagonals going down, which if you look at my picture, I circled those, and those are the extremes, equals the diagonals going up. And I also circled those. So when you were cross multiplying, make sure you get rid of all the ratios, because if there's still ratios left, then you didn't really multiply the way you were supposed to. In number 3, what you want to notice is that we got to keep parentheses around this y plus 1, because when we multiply the pieces together, the 2 needs to stay out in front of the y plus 1. So y plus 1 is still grouped together. The 1 and your 3y doesn't matter so much, just because there's no plus sign within those terms. So next we need to distribute, so we can take 2 times y is 2y, 2 times 1 is 2, and we get 3y on the other side. If we subtract our 2y to the other side of the equal sign, we get 2 equals 1y. So y itself is equal to 2 in this problem. For number 4, I would like you now to solve this one yourself. So I'll help you first set it up. So AB is over BC, because AB is to BC. So we know that it starts out as 5 over 9. So then next we need to look at our sides over here. AB is 15 and BC is our 5R plus 2. So now I want you to solve it for R. You should have done this as your first step, and then after that, once we distribute, we get 25R plus 10 equals 135. Then when we move the 10 to the other side, we subtract 10. And you should have gotten 125. Then our R value itself, once we divide, gives us a 5. All right, for the next one, they give us the whole proportion set up, so we just fill in the different pieces. So BD we do not know, so I'm going to leave that as BD. DA is the 3. BE is 18. And EC is 6. So when we cross multiply, we've got 6 times BD equals 3 times our 18. Once you multiply, we get 6 times BD equals 54, and then once we divide, BD just equals 9. So that's one of the pieces we're trying to find. If I put that back in my picture, that means that the whole length of this side of BA is 12, because 9 plus 3 is 12. So BA is 12. For number 6, we need to set up a proportion. So we see Mr. Jones has taken a survey of college students and found that 90 out of 106 students are liberal arts majors. If a college has 7,596 students total, what is the best estimate of the number of students who are liberal arts majors? So he is comparing liberal art majors, so that's our 90, out of the total number of students. So we first need to set up our ratio, and that would be the liberal arts majors, and then it's out of your total students. So when we set up our 90 out of 106, that's one of our fractions. When he gives us that the college has 7,596 students, that's the total students. That goes on the denominator. And then we are trying to solve for the top of that fraction. So when we cross multiply, this is what your equation should look like. So now when we multiply those together, we get 63683. Sorry about that. 640. And then 106 on the other side. Once we divide everything, we get 6449.433. So we would circle answer choice letter D. For the last part, we're going to talk about scale drawings. So a scale drawing is a drawing that has the same shape as the object it represents. And a scale is going to be a ratio that we use to describe how the dimensions of the drawing are related to the actual dimensions of the object. So on a map, or here we have a scale model of a train that we are going to use, and this is our scale. So our scale is 1 inch out of 5.4 feet. And just like we did up here with the language or the liberal arts majors and the total students, we need to label where did those numbers come from. So 1 inch comes from the model itself. The 5.4 comes from the actual train. Next, they're going to give us a value of one of the top or the bottom, so either a model number or a train number, and we need to find the remainder. So on letter B, if the model is 10 inches long, how long is the actual train? Okay, so the part we do not know is the actual train, so that's the denominator. That means our 10 inches is going to be on the top. Plus, if you notice, the units is the same, but sometimes that could change. So next we need to cross multiply. So we're going to be taking our 5.4 times the 10 equals our 1x. So when we multiply that, we get 54. Now remember, we're trying to find an actual train measurement, and our measurements are in feet, so this would be 54 feet. For the next one, I want you to set it up the same way, but remember, you're starting off with the same original ratio that we were given for the scale. So we have the 1 inches, 5.4 feet. Remember, the top number is your model number, and the bottom number is for the train. So I want you now to fill in the remainder of your ratio and then solve for how tall the model is. All right, so this one, they give us the height of the train, and you want to find out how tall is the model. So since you do not have a model number, that's the top, and your train number should have been the bottom. So when you cross multiply, you'd get 13.5 feet equals your 5.4 times the y. So you should have divided by 5.4 on both sides. And your y value, or the model size, would be 2.5. Now remember, that is in inches since it's for the model. So 2.5 inches would be your final answer.